Welcome to PGSMaths. In this video we're going to be looking at frequency polygons and histograms with an even class width. Before we can draw a frequency polygon, we need to know how to construct a histogram. There are different versions of histograms, but the easiest one to draw is one where the groups are exactly the same size. If we look at this table, we can see that there is 10 difference between each of our numbers, and this is known as an even class width. This allows us to draw quite an easy histogram using frequency up the y-axis. It's important that when you are designing your scale that you spread out each space with the same number of squares between them. This keeps everything evenly spread out, so it's easier to compare the distribution of data. Because the frequency on my data doesn't go any higher than 5, then the frequency on my graph doesn't need to go anywhere above 5. Starting at 0 at the bottom, I'm going to label every 3 squares with the next number of my frequency. You need to judge how far this needs to go, or how much space you're allowed based on the amount of space you have on the paper. Along the bottom, we're going to label this axis as well. Now, a histogram is very similar to bar graphs, with the difference being that you label the axes and not the bar. Because our data starts at 60, we don't have to begin at 0 and count up. We can just use a small zigzag to indicate that there are numbers missing all the way up to 60. It would be a bit pointless if we included the first 60 numbers, because there'd be nothing there. From this point on, I'm going to label every 4 squares with the numbers that I need for my data. So we'll start with 60, then 70, 80, 90, 100 and 110, using a small dash to indicate where each space is on my scale. It's important to remember that whenever you're designing a scale that you label what the axis actually represents. So in this example, I know that the x-axis is going to represent weight in kilograms, and the axis up the side here is frequency. Now, I mentioned that this was going to look a little bit like a bar graph, because that's exactly what it is. We're going to be drawing bars. The only reason it's called a histogram is because we're using the scale to show where the bars are going to be placed. Now, the rest of this should be fairly self-explanatory. For the first box, we're going to draw between 60 and 70 and go up to a frequency of 2. So from 60, go up to a frequency of 2, and then back down again. And that's our first box. Between 70 and 80, so between the next 2 lines, we have a frequency of 1. And continue for each set of grouped data, making sure that each of the bars is between the lines that we specified on our scale. Now, this is a form of frequency polygon. We've shown our data, we represented the frequency in different height bars, but to be able to fully compare this, there's one extra step that we need. If you were asked to estimate how many people are 80 kilograms according to this data, we could say there were 5 people, because everything in that block adds up to 5 in total frequency. But to give a fairer estimate, we need to draw a frequency polygon. To do this, you take the midpoint at the top of each of your bars and join it to the midpoint of the next bar. Repeat until you've completed joining all of the bars together. Now it's best if you've done all of this with a pencil, because the bars themselves are no longer needed. This zigzag line is our frequency polygon and can now be used to compare data or to make estimations. If I want to know how many people are about 80 kilograms, I can now look at where 80 kilograms is and see that it actually crosses at about 3. What a frequency polygon does is it shows you, if there was an equal change between the groups, what would be the values. You can make estimates at different values now. If we wanted to know at 90, we could look here and see that there are 4 people. At 95 there are 3. And it's just an estimation using a frequency polygon. Well, here's the challenge of the day. In a similar vein, I've plotted 2 frequency polygons on one set of axes. We're looking at the weight of boys and girls in a class. But I forgot to write down what the key was. Can you work out which of these lines would represent boys and which would represent girls? Remember to give answers that explain your reasons. A lot of the time we have to use words in maths, so this is a good opportunity to show your understanding. Leave your answers in the comment section below. Remember to subscribe to us for future videos, or follow us on Facebook and Twitter at PGSMaths. Let me know if you have any future requests or any problems. I'll get back to you as soon as I can.